So here we are talking about the drift, which is one of the things that we're going to be talking about in this particular chapter. Uh, I have to say this that this chapter and the next one to this, okay, and they've also added the third one, which is very much correlated to these term structure. So there are three chapters for 2025. In 2024, we just had two chapters which talks about the term structure models, but now we have three. Okay, and it may appear to be a little bit complicated at first, but we'll try to understand as much as possible, and at the end of the day you will understand the intuition and it's not going to be difficult at all. Okay, so this is what the thought process here is. Let's go ahead and let's understand this. Okay, so this is what the overall chapter will look like. So the first learning objective, it talks about construct and describe the effectiveness of a short-term interest rate tree, assuming normally distributed rate. Now, what I've done here is that usually I have the learning objectives in the orange color itself, but this time I've just marked something here. That means in this chapter, we are talking about the normal distribution. We are assuming a normal distribution, okay, both with and without the drift. So this is just one simple assumption that we are taking in the entire chapter, that the interest rate. So what essentially we are doing is we are trying to find the interest rates for the very short term. So if this is the interest rate, let's say 5%, what it's going to be for the next, let's say, 1 month. Will it be 5.1 or will it go down? What's going to happen? That is exactly what we are doing within this entire chapter that we have. And we are assuming that the interest rates, whatever the outcomes will be, over a period of time, it's going to have a normally distributed distribution. That is one assumption that we are assuming here. So the first thing that we'll do is the term structure models that we have. First thing that we will do is we'll try to figure it out using no drift at all. Okay, that means we'll just take the volatility, like, okay, it's going to go up or down. We just use that. Then what we do is that we add a little constant drift to it. Drift means any specific number that you add so that it has a movement, not random in nature. You are giving a direction. That is what drift means is. So in the second model, we'll just add a constant number or a drift. In the third model, we'll look at time dependent drift. And in the fourth, we talk about the Wasicek model, and that is going to be a mean reverting drift. So let's get right into it. Any doubts, any confusion, please either put it in the chat box or just you can raise the hand and you can speak. All right, so this is the overall intro of this particular chapter. Go slow and steady in this chapter. Okay, so here we have the very first model, which is no drift. Now, what essentially we are doing is that this is what the model looks like. The DR, what does D stands for? Change. Okay, nothing else. So the change in R, what is R? R is the interest rate. So the change in the interest rates, that is equal to nothing but the volatility. Like obviously stock prices, interest rates, they have a volatility, right? They are go up and down. That is a volatility. And what is this DW? DW is nothing but a random component. You have a volatility, but you multiply that with a random component, because why? Interest rates is a random variable. If you remember stock prices, it's a random variable. There is something, the previous day effects is there, right? But it's going to be random. We don't know what's going to happen. So DW is a random component or a stochastic component. We add to the, or we multiply that to the volatility that we have. So this is a very simple model. The change in the interest rate is calculated by multiplying the volatility to the random component. Now, this random component can take any value, okay? And again, it's a normally distributed random variable with mean is equal to 0 and standard deviation sigma dt. So you have to remember that sigma dt. Okay, so let's look at the notations here in the first calculation. So dr is nothing but the change in the interest rates over a time period. Okay, small time, maybe 1 month, 2 month, 3 months, whatever the situation is. Dt is a small time interval which can be measured in years, right? Uh, the sigma is the annual basis point volatility of rate changes. So that is the basis point volatility. And dw is a normally distributed random variable. So if you want to find the interest rate calculation, we're going to be using this particular formula. But within this particular model one, this is just for a short time period. Let's say we are standing here. This is time, let's say today. If you want to find t is equal to, let's say, 1 month, if you want to find what is going to be the interest rate at this time period, let's say 1 month down the line, then we're going to be using this particular formula, because from here the interest rates will either go up, down, whatever the volatility is, and it's going to be multiplied by dw, the random variable, that any number that we get. So this is one thing. The other aspect that we have is that we can find the change in the rates using a binomial distribution. So you can start from the rate, which is, let's say, whatever 4%, let's take it 4%. Then there are two possible moves, right? Either it can go up or either it can go down. So when we have a binomial event, okay, then the dw, the obviously the mean is 0, right? The average is 0. So 0 multiplied by dt is going to be 0. So the only thing that's left out is dt. And that's why you have the sigma multiplied by square root of dt. What is dt? Square root of time. So if you're finding it for 1 month in this binomial tree, what is dt? dt